Welcome to your algebra week of August 30th recording. We are heading into week 3, and you will find your assignments this week in the weekly assignments notebook. Do note that we do not have school on Monday due to Labor Day, so I did make your assignments due on Friday this week so that you can enjoy your nice long weekend with no school on Monday. All right, so at this time I do want you to make sure that you've got your math notebook out and that you are ready to take notes. I am asking that you take notes as you watch the recording, and it's only because it's going to help you in the long run by having notes to look back to, as well as being more of an active participant as you watch this recording. I have 2 warm-up questions that I want to start with, reviewing what we did last week in solving absolute value functions. So this will be a great review, and you can solve these on your own and then check your work with mine to see if you're doing these correctly. So at this time, I'd like you to click pause, and I'd like you to try to solve these 2 absolute value functions in your math notebook. And then when you're ready to check your work with mine, go ahead and click play. Okay, so what are the steps? How do we solve absolute value functions? So the first step is we want to isolate, which means get alone. Isolate the equation in the absolute value notation. So that means get the equation alone in the absolute value notation bars. And in our first one, that's already done, right? Our equation is already isolated. There's no numbers outside of our absolute value notation. So since that there's no numbers outside, that means that this equation has been isolated. And then we're going to set 2 equations up. One is going to be for the positive value 8, and the other is going to be, we'll set the equation equal to negative 8. So we're going to set up our 2 equations, so let's go ahead and do that. So one of them is going to be 2x minus 4 equals 8. And the other one is going to be 2x minus 4 equals negative 8. So the only thing I changed was setting it equal to 8. One is going to be equal to 8, and the other equation is going to be equal to negative 8. Because remember, what absolute value notation means is the distance away from 0 on the number line. So we can be 8 units away from 0 if we're in the positive direction, and we can be 8 units away from 0 if we go in that negative direction. And that's why we set one of our equations equal to negative 8 as well. And then we're simply just going to solve both the equations. We're just going to solve them. So here we go. Let's do the solving. So to solve for x, I'm going to start by adding 4 to each side. And then I've got 2x equals 8 plus 4 is 12. And now I'm one step from being solved for x. X is being multiplied by 2, so I'm going to do the opposite. I'm going to divide each side by 2 to solve for x. So x would equal 12 divided by 2, which is 6. So that is one of our answers. Now we need to solve this equation on the second one where it was equal to negative 8. I'm going to start by adding 4 to both sides. Now I've got 2x equals negative 8 plus 4 is negative 4. And then I'm going to divide each side by 2. Negative 4 divided by 2 is negative 2. So those are my 2 solutions. I have 2 solutions because I set up 2 equations. One with a positive 8 and the other with a negative 8, because we have to talk about the distance from 8 to 0 on the number line is 8 units. So we can have it be 8 units away from 0 in the negative direction and in the positive direction. That's why we set up 2 equations. What about the second problem? So we're going to do the same thing here, but in this case, if we look, our equation is not isolated. So we've got to isolate just what's in the absolute value function. So we've got 4 being multiplied on the outside. So our first step is to get rid of that 4. We're going to divide each side by 4. That's our first step, is to isolate the equation. When we do that, then we're left with x plus 2 equals 3. 12 divided by 4 is 3. And now we can go ahead and set up our 2 equations just like we did with the equation number 1. So our first equation would just be x plus 2 equals 3. We don't change anything. And then our second one is where we make it equal to that negative 3. So notice that I didn't set up my 2 equations until after I was able to isolate the equation that was in the absolute value function. Then I set up my 2 equations. I didn't do it before. I had to wait until I isolated the equation that was in those absolute value notation. All right, now we're just going to solve, add or subtract 2 from both sides to solve for x. X would equal 1. And we also are going to subtract 2 from this side. Negative 3 minus 2 is negative 5. So those are my 2 solutions. 1 and negative 5. And that's it. So that's our quick review on Unit 1, Session 2 with absolute values. That was a good review of what we did, and now what's coming your way this week. We're going to do Unit 1, Session 3, which is about inequalities and just a review of the basics for inequalities. And then in Session 4, you're going to be looking at compound inequalities. So let's jump right in with some reminders for the week. Make sure you're checking your grades. I am grading all of your work from last week, so it should be done by the time you watch this recording. If it's not, it will be soon. It will soon be done. So make sure you're checking your grades and not only seeing what you got on your assignment, the overall percentage, but to actually go further and click on the assignment in the grades tab. If you click on that assignment, it will ask you to click on something again. You can open it up so that you can actually see what specifically you missed. And then also read my feedback. So I want you guys digging deeper than just saying, oh, I got a 70% or oh, I got a 50%. Click on the assignment and dig in deeper to see why. And I leave feedback to help you learn why you made some mistakes. And then the next important thing is to learn from your mistakes. Remember, you can redo low scoring assignments, but you need to know where you made your mistakes in order to improve when you redo assignments. Then also remember, you need to message me when you redo assignments. If you don't message me, I won't know you redid something and I won't grade it, so you do need to send me a quick message just saying, hi, Ms. Cole, I redid this assignment. Tell me what assignment. And then again, remember, you should be taking notes as you watch this recording, and you also need to be taking notes as you go through the lessons in Schoology. So if I ask to see your notebook and your notes you've been taking, you should be able to show me those. So it is required that you're taking notes, so please make sure you're doing that this week. Alrighty, so inequalities. Let's do a quick review of the signs that we use for inequalities. Greater than, we're going to use this sign here. It's a sideways looking arrow, and greater than is going to be in this direction. You read the inequality signs, you read them from left to right, so it's like greater than. Less than is going to be this direction. And then we also last year learned about greater than or equal, and that's just when you put a little one line below each of the signs. So greater than or equal or less than or equal, that can include a number because it says or equal to. Where greater than and less than is not going to include a number, it's going to be any number that's greater than. So like if we said x is greater than 5, x is greater than 5, it can't include the number 5. It could be 5.1, 5.6, but it cannot include 5. Whereas when we talk about greater than or equal to, like x is greater than or equal to 5, it can include 5. We could say that includes 5, 5.1, 5.6, 6, 10, 12, and on and on. Alrighty, so inequalities, some important keywords to review. At least, again, means greater than or equal to. So if you're looking at a word problem and it says at least, that at least is going to mean greater than or equal to. At least means greater than or equal to. It can include that number. At least means it can include it. So greater than or equal to. No more than means less than or equal to. No more than means less than or equal to. These are some key words that you might see when you're working with word problems. So make sure you write these down. More than just means greater than. Less than just means less than. So it's important to pay attention to those ones that mean less than or equal to or greater than equal to. Here's an example. You must be at least 40 pounds to ride the roller coaster. So which inequality sign would we use here? You must be at least 40 pounds. So at least, does that mean it can include 40 pounds? Or do you have to be like 40 pounds, 40.5 pounds or something? So at least means it can include it. So it means greater than or equal to, 40 pounds, meaning you can be 40 pounds and anything greater to ride that ride. All right, I'm going to go on, so if you need more time with this slide, go ahead and click pause. Let's write some more inequalities. Ellie must score at least an 85% on her test to keep her B average in the class. How would we write that? What would inequality would we use? At least, you remember it back here? At least means greater than or equal to. So it has to be greater than or equal to 85, what she scores on her test. All right, the next one, a number minus 2 is greater than 4. How would we write an inequality? So a number, we don't know what that number is. So I'm going to represent that with x. Minus 2, so a number minus 2, so x minus 2, is greater than 4. So we would want the inequality sign in this direction, greater than 4. Next one, Kate has no more than $20 to spend on groceries. No more means greater than. No more. She has no more than $20. So we could do it like this. M represents money, would be less than $20. That she has $20 or less to spend on groceries. All right. So graphing inequalities. This is another thing I wanted to chat about for this week's assignments. How you graph inequalities on a number line. And what's important to remember is when we're talking about graphing things on a number line, remember a number line is just our line with, we've got 0, we've got some negative numbers, and we can go in the positive direction. When we graph, we use circles, and we use open or closed circles depending on what our inequality sign is. So we use an open circle if our inequality symbol is greater than or less than. So make sure that you're writing this down. Open circle when we use greater than or less than. We use a closed circle, so we'll actually, a closed circle will fill in our circle, where up here we would just put in a open circle like that and not fill it in. A closed circle we use when we're talking about greater than or equal to or less than or equal to, because we're showing that we can include that actual number. We're showing that by closing the circle that we can actually include that number. So like if we were saying x is greater than or equal to 5, I would put my closed circle on 5, and then I would shade to the right to show that it's greater than 5. So here I graphed x is greater than or equal to 5. I graphed it on this number line. So I have a closed circle because I have greater than or equal to, showing that it can include the number 5. And because it is greater than, we shade to the right to show that it includes all the numbers greater than it. What about an example of an open circle? Let's do an example of where we'd have an open circle. And we'll do, how about x is less than 3? So I just put that right here, this inequality. So let's graph x is less than 3. So 3 is somewhere, right? We'll say 3 is here. So I'm going to put an open circle because it doesn't include 3. It includes anything smaller than 3, any number smaller than 3, but does not include it. So I would shade to the left. So that is how we graph inequalities on a number line. Is first we decide if we're using an open or closed circle. And then if it's less than, we'll shade to the left. If it's greater than, we shade to the right. Okay, so let's try some really quick. So if we were to say, I'm going to skip that first one. Let's do x, the second 2 here. Here's our lines. Number line 0, -1, -2, 1, 2 in the positive direction. So here it says x is less than -2. So are we going to use an open or closed circle? We're going to use open because it's not greater than or equal to, it's just, it's greater than. It says x is greater than, if I said less than, ignore me from before, but that is x is greater than -2. So it's not equal to, it's not greater than or equal to, so we just use an open circle. And then because it's greater than -2, we're going to shade to the right. So it would be open circle, shade to right to show all, it's going to include all the numbers that are greater than -2. The next one, let's make that greater than or equal to 4. So greater than or equal to 4. We'll go by 2's here. -2, -4. So since it's greater than or equal to, we're going to use a closed circle to show that it can include the number 4. So I'm going to put a circle over the number 4 and then shade it in, close it up. And then I'm going to shade to the right again because it's greater than. So that is how a quick review of graphing on a number line. You'll get to do that this week. Some steps for solving inequalities. So you're going to solve an inequality just like you would any other equation. So remember, whatever you do to one side, you do to the other. The only thing that's different is we have an inequality sign now instead of an equal sign. So the only thing that's going to be different is that if you divide or multiply by a negative number, you're going to reverse the inequality sign. So let's look at number 2 here. We've got -3x is less than 15. So to solve for the x, we're just going to divide each side by -3. So because we divided by a negative number, we're going to follow this rule here. If we if we multiply or divide by a negative number, we reverse the direction of the inequality sign. So now it would be x is greater than -5. That would be our answer. So just a quick review of solving for inequalities. I know you guys have done this before. The only time you reverse the direction of the sign is when you multiply or divide by a negative number. That's the only time you're going to change the direction of the sign when solving inequalities. I'm going to go on to the next slide, so if you need more time, we're not going to do number 1. I'm trying to keep this recording short. And we are done. So let me put up the key phrase assignment for you guys. So I've written up the key phrase question that you need to answer after watching today's recording. And the question is, when do you use an open circle when graphing inequalities on a number line? So we talked about when you use open circles and when you use closed circles. I want you to tell me when you use open circles. To get to the key phrase assignment, so remember you get 10 points for answering the key phrase question. To answer it, you're going to log into your math class in Schoology. Follow these directions. Go to the Materials tab, click on the materials tab, and then go to the weekly recordings and key phrase assignment folder, and then click on the week of 8/30. Make sure the date of the recording matches the date of the key phrase assignment. Type in your answer, and then you're done. Have a wonderful rest of your week, and let me know if you have any questions as you're working through the assignments this week.